All right, folks, it's Bass Action back in action here. This video is going to go very, very quickly. It's our next video that's going to be significantly longer. I'm just going to very quickly go through how some basic row operations work. And then in the next video, I'm going to show you how we're going to use this idea of basic row operations to actually solve systems of equations. So up here at the top, I just need to fill in a little bit of a blank here, just one blank, talking about what elementary row options are. So one elementary row operation is simply to take two rows in a matrix and interchange them, just reposition them in the matrix. The second elementary row operation would be to take an entire row in the matrix and multiply it by any constant that you wanted, okay? Theoretically, we could also do it not really by it doesn't even have to be an integer. It could be a fraction. It could be whatever you want to do there. Then the third elementary row operation would be to add some rows together. So these are really our three choices, and we're going to use those to solve our systems of equations. Now, what we're going to work with is an augmented matrix, and I'm going to talk about that on the next video. This one, I just want you to kind of see how they're going to work. So let's take a look. I've got three examples here of some things that we could do, and we're going to just work with a matrix. So what I want to do on my first one here, our first operation that we're going to do, is we are going to interchange the first and the second rows. That means that our third row is going to stay the same. So I'm going to talk about this a lot in the next video, and it's going to be, let's go ahead and always write the part that we know we're going to stay the same. Something for us will typically stay the same, especially early on in this learning process. So we're going to interchange the first and second row. So that means my first row is now going to become 2, a -4, a 6, and a -2. And the second row is going to now become the 0, 1, 3, and 4. So that's the idea of interchanging two rows. The next elementary row operation that I could do is multiplying by any constant. So what I'm going to do is I'm going to multiply my first row by a -1/2. So this is my row that's going to change. So what I'm going to do is I'm going to rewrite the second two rows immediately, because those aren't going to change for me on this problem. So I'm going to do 0, 1, 3, and 4 for my second row, and my 1, my -3, my 5, and my 2. Those two are going to stay the same. And then my first row is going to get multiplied by a -1/2. So it's going to become a -1, a +2, a -3, and a +1. Then my last option for an elementary row operation would be to combine some rows. So what I'm going to do on this one is I'm going to add the first row to the third row. So it's really my third row that's going to change. So my first two rows are going to stay the same this time. So I'm going to keep my -1, my 2, my -3, and my 1. I'm going to keep the 0, the 1, the 3, and the 4. And then I'm going to take what I had for row 1 and I'm going to add it to row 3. That's going to give me it's going to give me a 0, a -1, a 2, and a 3. Okay, so what I did there was I took my -1 and my 1, and that got me a 0. A 2 and a -3 was the -1. The -3 and the 5 is the 2, and the 1 and the 2 is the 3. Okay. So down here at the bottom, I've got a little bit of a summary and like what the purpose of this is, and then we'll move on to this in the next video where we'll get to the heart of it. When we do these specific operations, okay, this can allow us to find the solution for a system of equations. Going through these row operations is a process called Gauss-Jordan elimination, and what we're trying to do is get the matrix in what's called row echelon form. And a row echelon form, what it's going to do is it's going to specifically have ones down this diagonal. These values will all be zeros, and then these values over here will represent the solution to our system of equations. Now, that probably sounds super abstract, and when you get into the next video, which is significantly longer, you will get to see how that is actually working for us.